When you need to design any high-scale system, the set of questions and the set of topics to consider is pretty limited. Also, the set of answers is limited. For example, if you decide any social network application, then you are going to have users. Then you have the number of users that you have in this system. This is pretty constant, because if the application is successful, then it's going to be from hundreds of millions to a few billions at most. So it's capped and pretty strict. In addition, usually what is happening in all these social networks applications is that some users are uploading content and some users are consuming them. Some users are following other users, and then users have the feed of other users. So you see, we have a few patterns, a few design choices to make, which is pretty limited. The capacity estimation to the system is also pretty capped, because you have the number of users, you have the estimation of the number of posts, of the number of pictures that these people upload. Then you have the design considerations of the user feed. What are you going to show in the feed? And whether you can optimize it in a way that when I want to view the feed, let's say of any application like Facebook, Instagram, whatever, then I can see my feed immediately. And not only can I see my feed immediately, I can also see that I get changes. So if someone is uploading a picture or a post or a YouTube video, then I get this notification and I'm aware of it. Another design consideration is the reliability of this application. For example, it's going to be pretty strict that if I upload a video or upload an image or upload a post, a text, then I want it to be reliable. I want this to exist in the system. I don't want it to disappear. As opposed to viewing the feeds where it's not that strict, that I want to be as much as reliable in being able to see all these feeds, because I could always see it on the next time. And all these can be solved with standard solutions. For example, for reliability, then most of the solution would be to have redundancy on the image that I uploaded, or on the user feed. Then if I want it to be fast and to get all the answers fast, and instead of querying all the 100 users that I'm following on the spot, and you will have millions of users which are doing this query, then I just compute it on the background, and so that when I want to view the user feed, it's already available. So I'll have a mechanism that computes it on the background, and so forth. Also, we need to understand that many of the videos in YouTube and many of the images are like 20% of them is viewed 80% of the time, even more, even 10% of them is viewed 90% of the time. So if you cache this bulk, then you will get a much better optimized system. So the basic concept of every such social application is the ability to upload stuff, the ability to share stuff, and the ability to have a news feed. And in general, our users should be able to do some searches on the system, to follow other users and to view the feed of other users. We do want such applications in a system design to be highly available. We don't want, so we want to prefer the availability of the system to the consistency of getting the latest photo. If you want the all the users that you are following, you prefer to get some results instead of a blank string because it couldn't get the latest tweet of your friend. Oh my God. Okay. And also, the latency for getting the feed from all your the people that you're following should not be more than 100 or 200 seconds. On the other side, let us repeat that the reliability is important on the side of the upload. So when you upload or when you tweet something, then in all these social networks, you want it to be pretty reliable. These systems are mostly read systems. And in general, you don't limit all the users on the amount of images that they upload, but you do want to never lose any image or any tweet that user makes. In general, in these kind of systems, we have, let's say, a few hundred of millions of total users up to a few billions. And in general, there is 1% of these users. So if you have, let's say, 100 million users, then 1% would be 1 million or even much less, 100,000 active users. So if you have 1 billion users in the system, then roughly something like 1 million or 2 million of them would be active. And those 1 million or 2 million users would upload a few images. So you'd have a couple of millions of images or tweets being uploaded. So the global scale is about something like something like a fraction of a percent, let's say, from 0.1%, 1 promille. 1 promille of the users are very active. So if one image is about 100K and we say we have a few millions of images uploaded, then we have roughly in one day about 1 million to 100K images uploaded, which makes for about 100 gigabyte per day. So this is the scale of the images that we upload per one day. But you want the system to be long-lived. So if you multiply this 100 gigabyte times 10 years, then you are getting into the scale of petabytes. In general, we store all these images, all these tweets, all these Facebook messages, all these videos that we upload in all the system. It's the same in some kind of an object storage, like a file system or something like this. And we have the objects, also in all these systems, we have the object like the tweet. The tweet has a tweet ID and it has a couple of metadata, so you can think of it as a single table. The tweets or the photos or the Facebook messages that you have, this is this table. Then you have also the table of the users, because you want to track also the users. Each such photo or tweet or Facebook messages or YouTube video have some kind of a foreign key or at least an ID that would point to the user that has uploaded this photo. And then you would have a third table which would connect all the users. So you could have a follow mechanism in between the users. So we have the tweets table or the photos table or the Facebook messages tables. And then you have the users tables. And then you have the connection in between all the users which are following one another. So you would have a connection on this table, or the only thing that you need is user 1, user 2, user 1, user 2. These are the two columns. So that you connect, follow connection relation from user 1 to user 2. To store only the table of the users, then you have a few fields. Each field, let's say user ID, it's a long, so it's 4 bytes. Name is a string, so it's longer, so it's going to be, let's say, 40 bytes. So email is also a string, so let's say 30 bytes. Okay, and if you multiply all these bytes into the total users that you have, then you get only to a few tens of gigabytes of memory. And in 10 years into 1 terabyte. So it's one scale down. We said that the photos or the high capacity items that we store is in 10 years going to be petabytes. In the case of users, it's only a few terabytes. And because we want to support a high scale, and we know that in all these social media systems, we have many more writes than reads, then we would probably want to separate the reads from the writes, to separate the servers, and in this way, to have a higher scale of the servers. And in general, in the reliability frontier, we don't want to lose files, so we store the files in multiple replicas, be it images again, tweets, whatever it is. You store it in a replica, and then when you store things on replicas, the question is, based on what do you partition the items that you store? So we could partition, let's say, all the photos or tweets, again, whatever it is, based on the user ID. But this is not that good because user ID can be hot. So even if we do a mod 10 on the user ID, some users are hotter than other users. In addition, some users they upload much of the content. We said that 10% of the users are uploading most of the content. In addition, it's possible that for one user, even one server won't be enough because we don't limit them. So we had better do all the partitioning on other aspects, such as the actual items that they upload, the actual tweets, the actual videos, the actual photos, the actual whatever that they upload. On this, we are going to do the partitioning. So for each photo that we upload, we need to generate, or on each item, we need to generate a new ID. And then comes the question again. It's a whole set of patterns that are repeating one after another. They are the same for all the design of all the social networks. It's all the same. So what is the point of failure in the generation of the key? So when we generate a key for the users, we could just have an increasing key. But if we have an increasing key, how can each server know which increasing key to have? 100, 101, 102, but you need to coordinate between them. And therefore, you may want a separate server in order to generate those auto-incrementation keys. But a single server is a single point of failure, so you can split it to multiple servers and let each server, let's say, handle one for you have the first server handle all the auto increment first one. Let's say it's generating the first key as 1, then 1 plus 3 is 4, then 4 plus 3 is 7. So it is generating an auto increment of plus 3. And the second server could generate the auto increment of 2 plus 3. And so forth. So you could have multiple servers generating such items. And in addition, in order to see the news feed, then, as we said, then the user can fetch the news feed immediately on the spot, on the moment, but this could be slow. So you might want to generate it all offline so that when the user gets its news feed, it sees it immediately. In order, then you have the question, when do I refresh the news feed of the users? Do I do a poll or a push? So in poll, all the clients are polling the servers, let's say every few seconds, and are trying to see if there is new data. But this would consume much traffic, and also in most cases, there won't be any new data, so it would be poll for nothing. So a better approach would be push to all these users. The data, as soon as it's available, you can do this with a long poll. The problem is that you have two kinds of users, the hot users and the cold users. And the hot users are having many updates, and they do get a high capacity. So you can have a hybrid approach where some of the users are having both pull and push into the data. And the last but not least thing is that in most of these systems, we have most of the items, 10% of the items are viewed by 90% of the people. So you just cache them, and in this way you get a great boost. So I think we covered most of the things that are available in designing such systems. First, the requirements. We usually have the newsfeed, we have the upload, which should be reliable. We had then the fetching. We then have some basic concepts about the scale and the size of the system. So if it's photos, then 100K or 1 megabyte per photo, and then you get into a daily amount of 1 terabyte. In the users table, we said also that we have 3 tables, one for the actual items that people upload and one for the users. In the users front, we have a few fields like username, user ID, etc. Each of them is a few tens of bytes, which bring us to about 1 gigabyte per total users. A few gigabytes, which is one scale down from the total content. In the frontier of the high availability of the system, we want to separate the reads and writes, and then we do also sharding and multiple replications of all the items, so that each item that you upload resides in multiple things. And as for the newsfeed and the ranking algorithm, then what you do is you generate all this offline, so that if you want to get everything in sub a millisecond or a few milliseconds, you want to get the newsfeed, and you already generated it. Everything offline, which is you have some servers that working continuously and are continuously generating the newsfeed. So this was it. This was the repeating patterns in all these system design issues. Hope you enjoyed it. I think this was pretty interesting. See you next time.